we're going to be analyzing the equation for an ellipse. If you look at it, it is on your yellow formula sheet. It's right underneath the parabolas that we have been looking at. And what's up here on the board is a demonstration that we could have done had I been prepared more. You can create an ellipse with a self-made compass of sorts. The compass is a little different because it's not a circle, which ellipses and circles are very closely related to each other. The problem is an ellipse is really what you guys used to call an oval. So the radius is not consistent around the shape, so therefore it doesn't make a circle today. It makes a weird oval. The idea is if you were to take a string and somehow affix it from one focus point to the next, they're going to call them foci today. That's the pluralization for focus points. And then you take your pencil and you kind of like pull it taut, and then you start drawing around while keeping it taut. You're going to create an ellipse. And what happens is when you have to freehand an ellipse, they're going to look a lot like a football. Yeah. Hopefully you guys have better luck than I do graphing. You'll see what I mean in a minute. The idea is the distance on these two pieces of string, when you add them together, it should be the same distance as the string originally before you started pulling it tight to the edge of the ellipse. So that derivation of that formula, and I remember doing this derivation in college, it actually wasn't too bad. They came up with the conic form of the ellipse, which are these guys. So they look exciting. So kind of some resemblance to the circle formula, which makes sense because the oval and the circle are pretty closely related in our little kindergarten brain. But the idea is you're going to have some vocab today. You're going to have a major and a minor axes for an ellipse because one of the axes is going to be longer than the other. We'll learn tomorrow that the closer it is to a circle, the more round it is. That changes what's called the eccentricity. So we'll talk about that tomorrow. But for now, some vocab. So major axes is just the longer axes. So it could be vertical, it could be horizontal. And you really have to kind of focus on this question. You have to focus on this question as to which type of ellipse you're looking at, because look at these formulas, guys. When you are adding two things together in math, you could flip that around, right? So you have to be careful. And for ellipses, the major axis is the larger axis, and that has to be synonymous with the number A in your head when you go to look at the formulas. So you have to be careful on ellipses. They're easy to confuse the formulas. I always, even if you graph like me, I always suggest you guys give yourself a sketch on ellipse questions in particular, because I think the formulas, while they're very interesting and easy to use at first impression, they're easy to confuse as well. So little sketch, confirm what you're doing in your formula with what you've sketched, because actually the sketching of it's very easy. It's the other stuff that's kind of annoying. So minor axes and smaller axes, you're going to have vertices that are on the major axes, and then the little guy, we call them co-vertices. So on the test, it's going to very specifically say, what are your vertices versus what are your co-vertices? Do not confuse them. You have to have major versus minor axes there. And then there's going to be two focus points, which we're going to call foci today. So the foci, remember that little demonstration on the other screen? That would be where they put the push pins on the end of the string. That's the same idea as a foci, or the foci. All right, let's see this in action. There's one more thing we're going to have to calculate today, and that's the value for C, which is the distance from the center of your ellipse to either one of the foci along the major axes. So the derivation for C looks a lot like Pythagorean theorem, and it should. This gets a little confusing, guys. We're not going to test the conic sections until we get all four of them learned, so we have hyperbolas still. All of the formulas look really close together. So like when we learn hyperbolas on Thursday, you're going to go, oh my gosh, that looks a lot like the ellipse formula, but like there's this one key difference. Well, that one key difference makes a huge amount of difference in your calculation. So please be very careful about your formula usage. All right, the first question is done for you, I bet, isn't it? I'm going to watch for now. I don't necessarily follow my formula sheet word for word, like step by step. What I do when I have to graph an ellipse is I start by finding some obvious things to me, and then I kind of move over to my graph. Now, I didn't even give myself a coordinate plane. That was a little silly, wasn't it? Gonna need a little help in my graph here, guys. So let me find myself a coordinate plane real quick. Probably. Sure, we'll use that. Okay. So the first thing I identify is the obvious thing from you guys, which would be the center of your ellipse. So the center is always located at HK. Just remember H is grouped with the X, K is grouped with the Y. So when you look at this formula, your H and K, there's H and here's K. They both have built-in negatives. So the center is at -2, +1. So on my coordinate plane, I would graph a center point at -2, +1. So the next thing I notice for an ellipse, I look for the largest denominator. So right here, this is the largest denominator. That is going to be the denominator that helps me with my major axes, largest one. But this is b squared. So if b squared is 25, that means b is, no, that's not b. Abruzzo, what are you doing? That's a. So this is a squared. I just major and I wrote minor. All right, so a squared is 25. That means a is 5. But this is where it gets confusing when we start to learn the next conics. Because a, the major axis, is written underneath your y factor, that means you're supposed to move in that direction. So you're going to move 5 units both up and down from your center. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Now, I believe it's pretty drawn for you on your paper. And knowing your textbook, they probably counted weird. Did they count by 2s or something? Yeah, not a big fan of that. I wouldn't suggest you do that on your homework, but it's up to you. All right, so then the other number, the other denominator, this is your minor axes. It's going to help you find your minor axes. And that is represented right now by b squared. So if 9 is b squared, that means b must be 3. So the minor axis is underneath the x factor, which means you're going to move left and right. 3 units from the center. So 1, 2, 3, boom, and 1, 2, 3, boom. And then you're all in for a treat because you get to witness what it looks like when I try to graph. Yep. Oh, I'm going to go ahead and fix that. That didn't turn out like I wanted. I really panicked there. All right. Yep. That's about what you get when I draw an ellipse. Now, that ellipse, to be fair, that ellipse, hey, was almost too round. I mean, it's almost a circle, right? So close. Oh, it's so bad. No, I'm on a tablet. Calm down. All right. Here's the point, guys. I'm not going to be too picky about your pictures. It's good news. Let's talk about some other things we'd have to calculate. So one of the next things I would calculate now, so I'm going to move over to my calculation side of my notes. I would find the value for C. So C is calculated. There's a little thing on your formula sheet where it says C squared equals A squared minus B squared. So since I want C at some point in my formula, I'm just going to square root both sides of that and say it's A squared minus B squared, which we have both of those. This is A squared, and then minus B squared. So that simplifies to the square root of 16, which is 4. The reason I wanted to calculate that is because I'm going to use the number, the value for C in a moment. Here's what C represents. It is the distance along the major axes of where the foci are located. So from the center, if you travel up 1, 2, 3, 4 units, that's a focus point. And then down 1, 2, 3, 4. That's the focus point. Unfortunately, I graphed the world's ugliest ellipse, so you don't really see any sort of representation of what the focus foci do here. But just remember on ellipses, they're still inside the ellipse, and they're, depending on how round it is dependent on how far out from the center they are. Okay, we'll talk about eccentricity a lot tomorrow, but for now, let's just save that idea. Okay, now for the calculations. I've already technically plotted a lot of things that I need to find, but I want to go through the calculations on the formula, and then we'll confirm them on the graph. So next thing I would ask you to find on a test would be your vertices. Now your vertices are the endpoints along your major axes. I already found them. They're these blue dots that I tried to graph very unsuccessfully. But the formula for a vertical ellipse, if I'm looking right on my formula sheet, a vertical ellipse, the Make sure you look at the right spot. The vertices are h, comma, k plus and minus a. When you guys are working through your homework and when you're on your test, it's highly encouraged that you write down the formula before you start plugging numbers in, because these can get a little crazy. It's because they all look really similar, right? So for us, h was -2, a was 1, and then you're supposed to add and subtract the value of a, which is the half of the major axes of 5. Now, no pre-calc teacher is going to be happy if you say, here's my 2 ordered pairs, because come on, guys, you're better than that. So I would want you to split these up, and you're going to tell me they are the ordered pairs -2, comma 6, and -2, -4. Now, even on my really awful graph, those blue points, I totally plotted at those 2 exact locations. So I feel like I'm on the right track at least, even with that ugly graph. All right, now my co-vertices would be the next thing that my teacher would ask me to do on a test. Co-vertices are the endpoints that you plotted on your minor axes, these red guys. So the formula for a vertical ellipse, finding the co-vertices, it is h plus and minus b, comma k. So that would be -2 plus and minus, I kind of lost what b was, 3, right? 3, comma k, which is 1. So again, your teacher would want you to split this up. So the first co-vertex would be at 1, 1. And then the next co-vertex would be at -5, 1. And these little red dots that I plotted are exactly at those 2 locations. So I feel like we've done some really good work here. Those green foci that I kind of started in, they can be found by using a formula that looks a whole lot like the vertices formula, because they're still on the major axes, but instead of going all the way to A units up and down, they're only going C units up and down. So for foci on a vertical ellipse, you have h, comma, k plus and minus c. Thank you. So for us, that would be -2 and then 1 plus and minus. Remember, a long time ago, we found c was 4. And again, we already plotted these, so I kind of already know where they're at. I will warn you guys, foci points, usually they're not pretty. It's like 2 plus square root of 3, like something gross, so be careful. So this is -2, comma 5, and this one is -2, comma -3. So apparently those green little stars I drew in are at those 2 points, which they are. Yay! All right, so that's what it's going to look like in your homework. So the very first question gives you a formula that looks like this, and they want you to graph it. So you're going to have to find all those things, and it's going to be a good time. The good news is you don't have a lot of homework. Like always, it's like 8 questions for each section we do. All right, take a look at one that's not done for us. So remember, the formula for ellipse, because you can reverse the order of the terms, you have to be careful about who's major and who's minor axes. So let's start by getting the obvious stuff out of the way. Where is the center of this ellipse located? Yeah, that's 0, 0. So 16 is the larger denominator out of the 2, so that's your major axes. And if 16 is a squared, think backwards now, what is a? A must be 4. So then your minor axes, 9 is b squared. So if you think backwards, that means b must be 3. And while we're at it, let's go ahead and just calculate the value for c, because we know we're going to need it. The c value is the square root of 16 minus 9. This time it's not pretty, so we're just going to leave it as the square root of 7. Now, as far as plotting goes, if you were to physically try to move square root of 7 blocks, that would be a little difficult. You'd have to change that to a decimal. It's like 2.6 or something. Can someone confirm that for me? Okay. So add fun, they counted by 2s on your graph that they gave you. So keep that in mind when you're ever moving things. And that's where I want to go next. I want to go ahead and plot some stuff before I start calculating the actual ordered pairs. So center at 0, 0, got that. Your major axes is 4 units in each direction from the center. However, it's on the y component, so the major axis is going to be vertical this time. So 4 units up and 4 units down. Here we go. 4 units up, 4 units down. Minor axis is horizontal, 3 units in each direction. Oh, okay. So 1.5 blocks. Be careful because you're counting by 2s. All right, let's see your ellipse. Here's mine. It's gonna be really bad. One's very circular, isn't it? Man, oh, okay. Okay, yeah. It's like, girls, it's like when you first learn how to paint your nails and you're like, I can fix it. And then you just keep like painting over it and you're like, I can fix it. Yeah. Yeah. You know what we're talking about, Nick. Yeah. So bad. Okay. It's even worse when you remember, like, how long have I been graphing these? Since before you were born, kids. Scary thought. And that's what they look like on a good day. Oh, I didn't find the rest of the stuff. I was so excited. All right, we gotta find things, guys. Now, we already plotted them, but let's use our formula and actually actively find them because they're not always pretty. So, first thing teacher will ask me for are the different vertices. So for this is technically a vertical ellipse. The vertices are at h, comma, k plus and minus a. So for us, that would be 0, comma, 0 plus and minus 4. And if I was a nice lady, I'd let you just leave it like that, but I'm not. You're going to split it up and you're going to say it's 0, 4 and 0, negative 4. Now, some of you are looking at this graph going, why did you just make me calculate that? Because there's going to be times in your life where you don't have a graph or it's not a good graph or they're not nice numbers, so you have to be able to calculate it, okay? Co-vertices. Vocab, make sure you're on the minor axes now. So co-vertices for a vertical ellipse is found by h plus and minus b, comma k. Which I know you already found them, those red points. So that would be 0 plus and minus 3, comma 0. So again, split them up. Your co-vertices are at 3, 0 and negative 3, 0, which we kind of already knew, but it's nice to confirm. And then let's keep going. We got to find the location of the foci, but remember, you kind of could have snuck them in on the graph. Just be careful, this graph is counting by 2, so if you're moving like 2.6, you're just moving like, I don't know, more than a block. It doesn't matter at this point. What can I do to that question, like make it look any better? Well, probably shouldn't add foci to the picture, that's my guess. All right, so foci on a vertical ellipse are found by taking h, comma, and then k plus and minus c this time. So that'd be 0, comma 0 plus and minus the square root of 7. Gross. Now, I'm actually kind of okay if you leave foci like that, but technically, we should be splitting that up into 0, comma square root of 7 and 0, comma negative square root of 7. And if you wanted to add it to your picture, it would be like here and here. Totally. That made all the difference. Those green stars really helped me out. All right. So graphing ellipses is really not bad. And if it wasn't for the list everything out very specifically, these would be very easy questions. Like if it just said graph, like you'd plot the center, you'd count, you'd throw a really ugly shape down and you'd be done. But unfortunately on your test, I do make you kind of go through the gamut of listing out the location of all the foci, the ordered pairs, the co-vertices, vertices. All right, so on the back now, it's going to be more of the same. So I think what I'm going to do is, I think we'll just do one more of these and then we'll get to the good stuff where it's a little more exciting. Because these can be really redundant, very repetitive. Let's just go ahead and do number 2. So we have a center located at, remember, built-in negatives, so -5, -2, always at HK. And then we have our major axes can be found by figuring out this value. This is your a squared. So your value for a is 8 units. And this guy is going to help you find your minor axes. That's b squared. So your value for b would be the square root of that, so 5. While we're doing some calculations, let's go ahead and quickly calculate c. It is the square root of a squared minus b squared. Is that 39? Okay, square root of 39. So that's not pretty. 6 point something. 6.2-ish. Ish. Yep. No? Wanna go with it? Yep, okay. So let's start plotting some things, then we'll come back and calculate things specifically. On counting by twos again, why not? All right, so -5, -2 would be halfway between here, and then this is -2. There's the center of your ellipse. For your major axes, be careful, guys. This time, the major axis is underneath the x-coordinate. So the major axis needs to move in the horizontal direction. This is the part that I always mess up, and then I do it in 10 like an idiot. So try not to do your homework in 10 in case this happens. So horizontally, I'm going to move 8 units, but remember, they're counting by twos, so you're moving 4 blocks each way. So 1, 2, 3, 4. There's one endpoint for a vertex. And then 1, 2, 3, 4. There's the other one. And then for our minor axes, I'm moving 5 units vertically because it's under the y coordinate. So that'd be 2.5 blocks. 1, 2. And there is absolutely no way I'm going to get this to look right. So here we go. Just worry about your own ellipse, people. Oh gosh. You know, I had like a moment there where I thought it was like down here, I was like, oh, it's going to be so good. And then, yeah, when you put all 4 parts together, it doesn't look a thing like an ellipse. So that's really unfortunate. If you want to go ahead and mark some foci points down, you're going to count, quote, you know, about 6 units, but remember it's by 2, so it's like a little over 3 blocks, huh? 1, 3, so like right here maybe. Yeah, that made a difference. That really helps. Now y'all can tell that's an ellipse, right? Mm-hmm. All right, let's go calculate some things. So your vertices. I'm only talking about the endpoints on your major axes. If you can already figure out where they are, technically you can just list them out, but I like to use my formulas to confirm I haven't done anything weird. So for a horizontal ellipse, the vertices are found by taking h plus and minus a comma k. I just can pull that straight off the formula sheet. So for us, that would be -5 plus and minus 8 comma -2. And again, I would expect you guys to split that up into 2 ordered pairs. So what do we have here? 3 comma -2 and -13 comma -2, which is exactly where I plotted those blue points. Go me. Now your co-vertices are the red points that I plotted, which if you can see where they are, you can technically just give me that, but let's go ahead and calculate them. Co-vertices on a horizontal ellipse are found by taking h comma k plus and minus b. So -5 comma -2 plus and minus 5. Splitting those up. That would be at -5 comma 3 and -5 -7. I'm just going to go back to my beautiful picture and make sure that it worked. Yeah, I'm going to go with yeah. I think that's where they're located. And then the foci. We're located on a horizontal ellipse. They're located at h plus and minus c comma k. So notice the vertices and the foci formula are almost the same on either type of ellipse, except this one you add the full a distance, and on foci you're only adding a distance of c. So I think we found C a while ago. That was the square root of 39, which doesn't reduce. If you have a radical that reduces, like square root of 27, square root of 20, I need you guys to actively reduce that like you normally would in PreCalc. So this is what? -5 plus and minus the square root of 39. Yuck. Come on, -2. Now, I'm actually okay if you just stop and leave your answers like that. But technically speaking, these do split into -5 plus the square root of 39 comma -2. Ugh. And -5 minus the square root of 39 comma -2. Yuck, yuck, yuck. Apparently that's where I plotted those green stars. Foci are ugly, usually. As long as they're in, I had a kid one time graph their foci on the outside of the ellipse. And like proudly too. Like, yes, that is where the foci is located. And I thought, man, I missed the boat, man. We need to revisit that. Foci are inside of your shape, okay? Number 3, number 4, it's pretty much the same. Let's do something more exciting. Look at this. So this one's already worked out for you. You get to just watch me work through this question and help me out. We're going to be completing the square because obviously this is not anywhere in a form. And the real goal at the end of the conics unit is that I should be able to give you anything in standard form, which is that standard form, and you should be able to complete the square with it and figure out whether you have a circle, a parabola, an ellipse, or eventually a hyperbola. And then once we do that, you also are going to calculate eccentricity, and then you'll know what that is tomorrow, and then we'll talk about what eccentricity means for each type of conic. We'll get there. For now, just watch. We're going to complete the square on both the x and the y. Here's how I know this is an ellipse without being told. When you look at the x squared and the y squared terms, they have coefficients in front of them that are not the same thing. So that's how I know this is an ellipse, because it's like something times x squared plus something times y squared. That creates elliptical shapes. So completing the square, starting with, it technically doesn't matter, because remember, in an addition problem, you can reverse around however you want. I just always start with the x's because I have it. I'm going to group the x's together. However, there's a 4 in front of that x squared. You have to factor it out. So factoring the 4 out of that, you still have to come through and complete the square. So this is, let's see, x squared. But then this is now a plus 6x. And you're going to complete that square in a minute. You're going to do the same thing with the y's. But there's a 9 in front of the y squared, so you got to factor the 9 out. So that's y squared minus 4y. You're going to complete the square. This 36 basically just needs to get out of the way, so I'm going to subtract it over here. But then remember, all the stuff you were adding, you have to add to the other side to balance it out. So here's the fun part. What's going to go in this blank right here to complete this quadratic? That'd be a 9. But you're really adding what to the equation? Really a 36. So to balance everything out, this blue blank is really a plus 36. Now on this guy, I know this blank is going to be a 4. Half of the squared is a 4. But what did you really add to the equation? A 36 again. So this green blank, to balance it out, you have to add another 36 over there. All right, so looking at what's going on here, this blue part, the 4 stays out in front, but this quantity, because you completed the square, you can factor it into x plus 3 squared. Thus, there's still a 9 in front of this one, and then this quantity factors into y minus 2 squared. And then on a good day, I can add, so that's 36. Clearly it's not a circle, because at first a lot of kids look at this and they go, oh, it's a circle. But you can't have numbers in front of your factors like this if it's a circle. So what you would have to do next is you'd come through. Do you remember how the end of the ellipse equation was always equals 1, equals 1, equals 1? Whatever this value is, you got to divide everybody by it. All right. So 4 over 36 is 1/9. But you're like, if you think about the form of the formula, just like a big denominator of over 9. So this is now x plus 3 quantity squared over 9. This guy is 1/4. So you would write down y minus 2 squared over 4. And then, of course, 36 over 36 is a 1. There's the ellipse. And now you would be blessed with the opportunity to graph. You'd find your center, you'd find the major and minor axes, you'd find the foci. It would be a good time. So instead of graphing the next few questions, what we're going to do is we're going to complete the square, get it into this general conic form, and then we'll get it into conic form, and then decide whether we have, all you guys know right now, parabola, circle, and ellipse. So those are the only 3 options today. Come Thursday, you'll have a 4th option, which is hyperbola. All right, off the top of your head, anyone want to take a stab at whether this is one of our big 3? Parabola, circle, or ellipse? Any thoughts? It's okay if you don't know. We'll just start investigating. Okay. So start collecting. I notice that we've got y squared and x squared in the problem. So I just kind of by habit always group the x's first, but you don't have to. If you guys want to group the y's first because they're already sitting there, that's totally fine. So let's collect the y's together. They're already there and complete the square. So y squared plus 2y plus, I don't know. Now when I go to complete the square on the x's, I have that factor of 6. You're going to need to take that out. So this becomes x squared is now a minus 4x plus blank. Someone already moved the 5 over. That was nice. And then you got to balance everything out. So plus the green thing and plus the blue thing. All right. So to complete the square on the y's, half of that squared would be a 1. And then to complete the square on the blue part, that would be half of this squared would be a 4. But what are we really adding to this equation? A 24. So watch out. Okay, so our green quadratic, y squared plus 2y plus 1, now that it's completed, you can factor it into y plus 1 quantity squared. Thank you. And then the 6 that we factored out stays in front of that factor for now. But this quadratic is going to factor into x minus 2 squared. And then let's see if I can add today. 5, 6, 30. So anyone developing any thoughts as to what conic we're looking at? Can't be a circle because of that 6 in front, so we must be looking at an ellipse. So to get it into perfect ellipse form here, you got to divide everything by a 30. Now there is technically a 1 in front of this, guys, so you can always divide by a 30. So here's what we have. We have y plus 1 quantity squared over 30 plus x minus 2 quantity squared. This is a 1/5, so over 5. That equals 1. Thank goodness they don't want you to graph that. That's ugly. This is definitely an ellipse. Come tomorrow, you'll be able to take that one step further and calculate the eccentricity. All right. The next one. Anyone have any brilliant thoughts about number 6 as to whether it's a circle, ellipse, or parabola? I heard circle and I heard parabola. I want you to fight over it now. Go. Just guessing. All right. I think it's a circle because x squared and y squared both have a 1 in front of them. All right. Take a look. Let's complete the square. Now, if I think it's a circle, speaking, I should put the x first. It doesn't really matter, but that's kind of the way we learned it, right? So I'm going to group the x's first. I'm going to complete the square in them. Same thing with y's. Someone already moved the 14 over. That was good. And then we're going to balance it out. All right. Blue blank. Half of 24 squared would be a 144. And then half of 2 squared would be a 1. So this factors into x minus 12 squared. Plus this would factor into, let's see, y plus 1 squared. And then sometimes I can add, let's see, 159. that 159? Cool. Oh, definitely a circle. Can you tell me the radius of that circle? Ugly number's fine. Square root of 159? So there's a question on your test where you're going to have to do that, and the radius comes out like to a not typical radius. Like you guys are used to algebra 2 questions where the radius goes something beautiful like 2. Sometimes radii are gross. Like square root of 159 is a thing. It's just not a very nice, it's not an integer, and that's okay. I think on the bookwork, there's some questions that look like this where they want to know what type of conic it is, and a lot of kids just write down, oh, it's obviously a circle, so they write down circle. But part of the directions will also say, write the equation. So, like, it's cool that you notice right away, oh, it's going to be a circle, but you do have to go through the completing the square, please. All right, number 7. Anyone have a thought as to whether this is circle, ellipse, or parabola? It is a parabola. What's the dead giveaway that it's a parabola? No x squared. So if there's only one term that's being squared, you're looking at a parabola. So because of the way that our formula sheet does parabola form, I want to get the y terms completed and all on the left side. So basically I'm shooting for this formula. So keep working until we get that. So keep the y's where they're at. Let's go ahead and subtract and add these terms to the other side. So we have y squared plus 4y. I'm going to complete the square. And then if we subtracted 4x over and we added the 8 over, okay, we're on the way there. But remember, I always forget to balance out my completing the square on these. I don't know why. All right, so to complete the square on the quadratic part right here for the y's, that would be half of the squared is another 4. So this, I can factor so it looks like this. It would be y plus 2 quantity squared. But this doesn't look like this yet, because what you have is negative 4x plus 12. So in order for this to look like this, you're going to have to factor out some number. A negative 4 would be brilliant, because if you factored out a negative 4, you'd be left with x minus 3. And then I think we're exactly in that form. So if we were on a test, probably this question wouldn't stop here. Like, yes, it is definitely a parabola. It's a horizontal parabola, right? Sideways one. What direction is it opening? Right or left? It's going left because of the negative p-value. What is the p-value, by the way? -1, thank you. And where's the vertex? Flip it around for me. 3, comma, -2. Yeah. It's always I know it's hard because they flip the formulas around, but it's always HK, always XY ordered here. All right. And I'm currently not doing number 8 because I don't have it. So this is not actually your homework. I think we scribbled out 25 from last year. It's even shorter. That's your homework, okay? So I haven't posted it yet for the answer key, but I'm about to post it. If you want graph paper, I've got a whole stack of graph paper back there on that shelf of stuff at the back of the room. We're going to do day 2 of ellipses tomorrow, which is just more fun. And then we got hyperbolas coming up, and then 2 days of hyperbolas, and then we're ready to test. I think we're eyeballing a test on Wednesday next week. Grades are due this week for me, guys. If you are missing a test, you need to get it made up immediately, okay? I have to post grades, and I got to put all these comments and things about how you're working.